So today we are going to talk about time complexity in big O notation. Before continuing directly or jumping directly into the data structure terminologies, let's understand in the real world or in a plain English what exactly the time complexity is. So the time taken by any algorithm as a function of the length of the input is basically the definition of time complexity. So that means how that a particular program or a particular algorithm function performs when we increase the length of the input. So in the plain words, I can say, let's say I am bringing a book from library to my home. So how much time I am taking to make that book reach from a school library to home is a particular length. That is the time complexity of that particular book. So let's say I have two ways to take a book. One way is I can commute via public transport to my home. The other way is the I can take a personal cab or personal car and come to home. So time taken between these two, like the public car and the uh, commute, the difference would be there. So that would be the time complexity of that particular function in which I'm making the book reach from my library to my home. So, in this diagram, you can see like the input size once starts increasing, we start finding the time complexity of a particular function. So, finding the time complexity, we have three type of terminologies to use. One is big omega notation, one is big theta notation, and one is big O notation. So we generally go with the big O notation. Big O notation is nothing, just that it just tells the maximum time an algorithm would take to compute its all the functions. Like this will be the worst case. This much time this algorithm would take to complete its whole process. So now let's say I have an array which has number from 1 to n and I have to find the sum of all the numbers. So there could be multiple methods to resolve a particular solution. So let's say I have one method which is n into n plus 1 by 2, and the other method other person is thinking is the for loop. So inside the for loop he'll start adding one into the other, then the third one, the fourth one, and going on like that. So there could be multiple ways to solve a solution, but later on, what matters is how much time that particular program is taking and how much earlier or how much like the complexity is there to resolve that particular problem. So now let's start with the simple loop. So let's say I have a for loop. Uh, I is equal to 1, I is less than equal to n, and then I plus plus. The very simple loop which we see in our very daily life, right? So let's say some constant thing is happening inside x equals to, let's say, y plus z. So we know inside this particular function some constant thing is happening up here. So this particular thing will take constant time. So let's say this constant time is c, and for how, so I is starting from 1 and it will keep on working till the time I is less than equals to n, right? So this particular for loop will run for n times, and inside we have some constants. So the complexity for this time particular for loop would be c of n, where c is the constant and n is the particular length given at the runtime for that particular program. So we know that we just ignore the constants while we are calculating the time complexity. So for this particular function, we will have the complexity which is n, because c we will be ignoring. So now let's start calculating the nested loop after the plain loop. So let's say I have a for loop inside which I have again a for loop and some constant expression is happening there. So the outer for loop here will have the time complexity of n, since it's running till the time of n, and the same case is happening for the inner loop where j is less than equals to n. So as we know, the internal statement is a constant, and the constants are ignored when we are calculating the time complexity. So n into n, we will say the complex time complexity for the particular this nested loop where the expression thing is constant is n of square, that is O of n square. So now let's start with some sequential statements. So let's say we have a first statement a equals to a plus b. So we know this is it will take some constant time. Let's say the second statement is for loop, the basic for loop, which is running till the time of a particular length, which is n here, and doing some constant work inside, which is x equal to x plus y. And the third statement for loop with the j equals to less than equals to n, it will run till the time it matches this particular length, either equals to or less than. And again inside it, a equals to b plus c is a constant time which it will be taking. So let's say a equals to a plus 1 is constant time c1. The second for loop, let's say we have for c2 is let's say I'm denoting c2 with the second constant time here, which is taking particular n time for the runtime, and the third one is taking again n. So let's say c3, and because c3 I'm denoting here to the third constant. So while we will be doing the addition of c1 plus c2n plus c3n, we will be removing the constants, because we remove the constants while we are counting the big O notations. So while we remove c1 plus c2n plus c3n, it will become O of n. Question comes, how do we calculate the big O notations for the if-else statements? So let's say we have a program where we have some conditions inside the if block and some conditions and statements inside the else block. So what we do here is we let's say we have some uh, conditions which are giving us the big O notation of O of n in the if condition, and else condition is giving us O of n square. So generally what we assume here is that if condition is the good condition and else is once if condition is not happening. So else condition is already the worst condition here because the if is not happening. So here what we consider is O of n square is the time complexity, because the O of big O is actually the worst time it will take to complete any particular program. So now I will mention all the time complexities in the sequence in which they are considered from good to the worst. So first, the best case is considered to be O of 1, and then we consider O of log n, then O of n, O of log n log n, then n square, then 2 raised to power the n, and in the last, the worst case is O of n factorial. So to take an idea of it, I'm just putting a diagram below here to take a look here, like how the excellent are considered O of 1 and O of log n, and how the horrible are considered O of n factorial here. So thank you so much for giving your time, and I hope you have got some idea how the time complexities are calculated and are used in the programs. Thank you.